So far, we have assumed that the rectangles were fixed. In practice, it's not the case. An activity may have some freedom to execute within its time intervals. Okay? During the exploration of the search tree, the activities are not all fixed. Okay? So we need to deal with this case when we implement the checker. Okay? The fact that the rectangles are not fixed. So how do we do this? So if we take an activity I, like this one, it can execute inside the rectangles. But for some activities, you may detect what we call a mandatory part. A mandatory part is an overlapping region for that activities that will always be overlapped. So if you take this activity I, if you schedule it at its earliest time, you get this. Okay? If you schedule it at its latest time, you get this. And you see that this region is a region that will always be overlapped, whatever you decide for the starting time of this activity. Okay? And so this mandatory part will exist if the ending time of I is larger than the maximum of the starting time. Okay, so these are two variables. So I'm referring here to the values inside the domains. So if we have this, then it means that there is a mandatory part for this activity. And this mandatory part, of course, will also consume CI, the consumption of the activity I. The mandatory profile is a profile that is computed only based on the mandatory parts of the activities. Yes, because as I already said, during the search, the activities are not fixed. And so we have to deal with this case. And we will create not the resource profile, but what we call an optimistic resource profile that will only be computed based on the mandatory parts of the activities. Okay, so I take for every activity I do this, I compute the mandatory part, I extract it. Okay, this is a fixed rectangle, and then I compute the profile with the sweep-line algorithms based on these mandatory regions. And of course, it's very optimistic because these mandatory parts that I have extracted from the activity, I know that they will be larger at the end once the activity will be fixed. But since I don't know how they will be fixed, I can only rely on the mandatory parts of the activity to make the check that we do not that we do not exceed the capacity of the resource. And the timetable filtering algorithms is the idea that we will update the lower bound of the activities, of the starting time of the activities, based on the optimistic resource profile. So first, step one, I compute the optimistic resource profile based on the mandatory part. This is a step one of the filtering. Once I have this, I take each activity and I compare it to the resource profile. So I take this activity. You see that I have a bit of a slack. This is what we call a slack here. It means some space above the optimistic resource profile. And clearly, I cannot start the activity there. I cannot start it here. Because if I do this, here it's okay. But then here, you see that the slack is not enough. I would exceed the capacity C. And so I cannot decide to schedule this activity as early as this time because I would exceed the capacity here. So I need to push the activity at least to that point. Because starting from there, it seems that I'm able to schedule the activity without exceeding the capacity C. What is the time complexity for doing this for every n activities? Well, for one activity, this operation will take me order of n. So it will be order of n per activity. Because you see that for every activity, I look ahead. Okay, am I exceeding here over the optimistic resource profile? Am I exceeding the capacity C? This resource profile has order of n rectangles, and so it takes order of n per rectangle to check where I can place at the earliest time each activity. And so overall, it will take me n squared because I have n activities to prune. You need to be very careful with the activities with the mandatory part because this activity, for instance, has a mandatory part, this one. You see the blue region is mandatory. It means that the blue region here, the blue region is already contained in the resource profile there. Okay, and so once you decide, am I exceeding the capacity of the resource if I would add this blue part here over the resource profile, you need to be very careful because this has already been accounted inside the resource profile. And so you should not push an activity later than the mandatory part of an activity because it has already been scheduled in the resource profiles. Okay, so although here we would like to push the activity maybe after B, so we would like to do this. We cannot because the blue region is starting earlier, and so we cannot push it later than this. Okay, and so this is invalid because the blue region has already been computed inside the resource profile, and so somehow it's a kind of support for this activity, and so we cannot push it later than the mandatory part of this activity, which means that we will only be able to prune this part of the activity like this.